In this third video, we're going to start by explaining what is a radian, and I'm just going to ask you to recall that when we evaluated in our first section in this chapter, when we evaluated using a sine, cosine, and tangent, I asked that you make sure and check that your answer was in, or your calculator was displaying an answer that was for an angle in degrees. Instead of degrees, there's another way of finding an angle measure. It's called a radian, and so that's why your calculators have two modes. We're not going to be using the calculator much in this section. Just to get you started thinking about, there's another way of measuring our angles. So this section asks you to explain how do you convert from one angle to another, from one measurement to another. It's like the difference between yards and meters, or feet and meters, or inches and meters, and things like that. So it's two different units that can represent the same angle measurement. So angles can be measured in a unit other than degrees. It's called a radian. So what is one radian? It's kind of like a visual thing to explain. Imagine we have a circle of any size. The measurement from the center of the circle to any point on the outside of the circle is one radius, is called the radius. Imagine if your radius was a piece of rope. Now, if you take a piece of rope that has a beginning and an ending that is this exact length, and you start wrapping that piece of rope around the outside or the circumference of the circle, the rope will end somewhere. It would start somewhere and end somewhere. The angle formed between this beginning and the ending of this rope inside of your circle, with the circle's vertex, or the center is the vertex of your angle, that forms an angle called 1 radian. That's how you measure an angle based in radians. It's based off of the radius of the circle. Now, does that mean if the radius is longer, does that make the angle larger? The answer is no, because everything is proportional. So what we're going to do is explore this in a little bit more specific way by saying, let's pretend that our radius of our circle is exactly 1 unit. If our radius of our circle is exactly 1 unit, then what we're describing here is something called a unit circle. And the directions say here, for a unit circle, we know that automatically does mean the radius equals 1. The circumference is how many units? Remember your circumference formula, it's a length. So pi, is it pi r squared? Is it 2 pi r? It's called like pi times d. That's the circumference formula. But if you're using and referring to a radius, it's called 2 pi r. This is the one that's going to help us. When the radius is 1, the circumference would be 2 pi times 1, or the whole entire length around the outside of a unit circle would be 2 pi, would be a length of 2 pi. This represents the entire arc length of the entire circle. There's one key that you're going to use more often than anything to understanding how to do this. That key is to help you convert degrees to radians and vice versa, is the relationship between not the full circle, but half the circle. In a circle, the entire circle is 360 degrees. Half of the circle would be 180 degrees. And 180 degrees is the equivalent of not 2 pi, but only 1 pi radians. This is critical. Okay, we're going to use this a lot. Before we get off to finishing how do you convert, what might help us is to do a factor, like a T-chart, for the number 18. And you may not see the relevance yet, but let's find out how many different ways we can factor 18. So 1 goes into 18 times. 2 goes into 18 9 times. 3 goes into 18 6 times. Now 4 does not go into 18, and 5 doesn't go into 18, but 6 goes into 18 3 times. Now I'm actually going to include one of those numbers I skipped over. We skipped over 4. How many times would I divide 4 into 18? 4 and 1/2 times, so 4.5. Alright, so what's the deal with this table? Why am I making this T-chart? I'm making this T-chart because of this fact, that 180 degrees is the same thing as pi radians. What we can do is use this to kind of cheat and help us to convert 180 degrees. So I'm going to multiply everything by 10. I'm going to multiply the top of my T-chart by 10 and my right-hand column by 10. So that makes everything into its degrees. Now if I multiply 4.5 by 10, I get 45. Okay, so now how many times does 6 go into 180 degrees? That's 30 degrees. And instead of saying how many times is this number, here's what I'm going to do. I'm going to take pi and divide it by 1. And that gets me 180 degrees. Pi radians equals 180 degrees. What if I do this? Pi divided by 2. Pi divided by 2 is 90 degrees. Pi divided by 3 is 60 degrees. Pi divided by 4 is 45 degrees. And pi divided by 6 radians is the equivalent of 30 degrees. Alright, why does this work? Because pi radians equals 180 degrees, dividing 180 by 6 gives us 30. Because they're equivalent, they are the same, they represent the same thing. So we're going to use this to fill this out. 360 degrees is the whole circle. That's twice this, so I'm going to double that. That makes 2 pi. 180 degrees, this was the key. This is the one that was the most important. I'll put a star next to it. 180 degrees represents pi radians. What happens when you cut this in half? We're going to cut that in half. Pi divided by 2 is 90 degrees. Now half of 90 is 45, so we're going to cut pi over 2 in half and get pi divided by 4. Now I see pi again. This is the second time it's listed. Pi radians, again, is 180 degrees. Let's see, 60 goes into 180 3 times. So what that means is if I divide 180 by 3, I get 60 degrees. So pi divided by 3 is the equivalent of 60 degrees. How many times does pi over 6 go into pi over 3? That's twice, so I've divided this by 2. Let's divide that by 2. 30 degrees. It takes a little bit of some time to sink in. You will likely come back to this video and watch it more than once. Maybe watch it a little bit later after some practice with this. It might make a lot more sense why we're doing what we're doing. At the bottom of this page, what we're going to do is convert radians to degrees and degrees to radians. There are 2 tricks to it. Aside from knowing the conversion that pi radians equals 180 degrees, we have like 2 methods to do this. To convert from degrees to radians, we're going to multiply the angle by the conversion factor. Now what conversion factor does is it converts it from one unit to another. So if you're going from degrees into radians, you're going to multiply by pi divided by 180. Pi radians divided by 180, if they represent the same thing, they'll cancel each other out more or less. This is what we're going to do with exercise 1. I'm not going to tell you the second one because it doesn't apply yet. So what we're going to do is we're going to take 225 degrees, multiply it by pi over 180. Now I'm going to go back to here. First I want to simplify my fraction. Then I'm going to multiply the remaining simplified expression. This will be a little bit easier for me to work with. Can you think of any numbers that go into 180 and 225? Now I think 5 definitely does go in, but let's use some of our rules for division. Now 1 plus 8 plus 0 is a multiple of 3. 9 is a multiple of 3, which also means that it's divisible by 9. I'm going to go over that again. 5, 6, 7, 8, 9. Okay, so if I add the digits together, that can tell me if it's divisible by 3. If the sum of the digits of the number is divisible by 3, then the number itself is divisible by 3. Now there's also another rule for division, for for dividing by 9. If the sum of the digits is a multiple of 9, then the number itself is divisible by 9. 5, 6, 7, 8, 9, 8, 1, and 0. Both of these are divisible by 9. They're divisible by 5, which means both of these numbers are divisible by 45. 45 goes into 180 4 times. 45 goes into 225 5 times. Our answer in radians, 225 degrees, is 5 pi over 4 radians. That's one way we can do this for question number 1. We could do some of the other degrees the same way. Maybe let's take a look at number 5. I'll just go down. Let's multiply by pi divided by 180 degrees. When we say these things convert, these conversion factor, it's going to cancel out those degrees. That's why I crossed those out. Let's find a number that divides 500 and 180. I know 10 goes in, both 10 goes in 50 times and 18 times, so that simplifies it a little bit. Can you think of another number that goes into 50 and 18? I can. I think 2 goes in. 2 goes in 25 times and 9 times. Looks like 25 pi over 9 is how you can convert 500 degrees into radians. Now, how do I know my answer is right? How do I convert it back? That's the second thing we're going to do. Since we know that pi represents 180 degrees, to check my answer, I'm just going to remove the pi and replace it with 180. Again, I like to always simplify and then multiply. 9 goes into 180 20 times. 20 times 20 times 25 is 500. So this answer was correct. This also tells you our second rule. To convert from radians into degrees, we're going to substitute out pi with 180 degrees and then just evaluate it. Let's do that for question 2. 7 pi becomes 7 times 180 degrees divided by 4. I know it's a lot easier. 4 goes into 180 45 times. It's like to divide by 4 means to cut in half twice. Half of 180 is 90, half of 90 is 45. Now that simplifies, now let's multiply. 7 times 45. 7 times 40 is 280, 7 times 5 is 35. 280 and 35 is 315 degrees. That was a little bit easier. Again, you want to simplify as best as you can. Now pi, or 180, does divide by lots of numbers like 1s and 2s, 3s, 4s, and 6s like we did in that T-chart up above here. Alright, let's see which other ones we're going to do. Let's take a look at question 3. 585 is an answer in degrees. I'm going to multiply by pi over 180. How do I know that? Because I want my units to cancel. I'm going to put 180 degrees on the bottom. Alright, let's see if we can learn any of the tricks. Like 585. It divides by 5. I know that. Add the digits. 5 and 5 is 10, and 10 and 8 makes 18. 18 is divisible by 3. 1 plus 8 plus 0 is 9, which is divisible by 3, but also 9 is divisible by 9, and 18 is divisible by 9, which means this number is not only divisible by 3, it's divisible by 9, it's divisible by 5, which means it's going to be divisible by 45. So 45 goes into 180 4 times. 45 goes into 585 13 times. The answer to question 3 is 13 pi over 4. Yes, of course, you can use a calculator to do this, but it's also good to know your rules. Last one, I think, in this top row is 4 times 180 degrees. I'm just going to replace pi with 180. 4 times 180 is 720. How do I know that? You're multiplying. Just like to divide by 4 means to cut in half twice. Multiplying by 4 means double twice. Double 180 to get 360, double it again to get 720. This is pretty much how you're going to evaluate each of these. I don't know if any others we're going to do. I'm just going to take a look at a couple more. Like this one, 20 times 180 divided by 3. 3 goes into 18 6 times, so 3 goes into 180 60 times. 6 times 2 is 12 times 10 times 10, so that's 1200 degrees. That's a quick one. Number 6, negative 120 degrees. Multiply by pi over 180. What number divides 120 and 180? That would be 60. 60 goes negative 2 times, and 60 goes 3 times, so in radians. Pretty much that finishes up this section in this video. We got one more video for you coming up next. You can work on these exercises and compare your answers to mine. Next video coming up.